so we are going to do some arc length today, and we'll practice some arc length, and then we'll get into, we'll do a little Euler, we'll do a little Maclaurin, kind of bringing it all back together again as well. We did arc length in class pretty much before we left, I want to say. So arc length, how could they ask you to find arc length? Well, it's going to be like the length of a path or a perimeter or something. Now, if something is a straight line, you know how to find that. But if something's a curve, you're going to have to use the arc length formula in order to find it. Now, we're going to start off with 5 problems that are just pretty basic, just so that we can get in the mood of arc length. And then after that, we're going to do 2 free responses. Now, I kind of cut the video that AP Central did. I'm going to do their first example, and I'm going to do their last example. So, let's say I'm going to do number 1 and 5. So 2, 3, and 4 are still in there. So if you want to go to AP and watch their video for 2, 3, and 4, by all means, you could do so. But I thought to kind of shorten our time a little bit, we'll take a look. And this number 5 is a doozy. It's pretty good. It shows you how to use Maclaurin, how to use Euler, but with a little twist to it, something that you wouldn't have thought of that makes it a little more difficult. All right, so number 1, quick check number 1. Consider the function f of x is equal to cosine 3x, right? But do not evaluate an integral that gives the arc length from 0 to 2 pi over 3. Now, this is just going to be very straightforward. So we're doing from 0 to 2 pi over 3, and we're doing 1 plus the derivative squared. Well, if f of x is equal to cosine 3x, the derivative of cosine is negative sine. And then don't forget the chain rule. So negative 3 sine 3x. So you have a negative 3 sine 3x quantity squared dx. Okay? So then you're done. Again, they told you not to evaluate. They just told you to go ahead and write the equation. Now remember, you've got a calculator, so even if they wanted you to evaluate that, you're putting that in your calculator. Being very careful with where you're putting your parentheses and your squared. Don't put your parentheses and square the 3x. Make sure you're parenthesing the whole thing. And I do want to show you that when you put in sine, let's say we're doing the square root of 1 plus sine. Now notice they already put the parentheses in. So if you do parentheses like that, you're not squaring sine of 3x. You're squaring 3x. So you needed to have a parenthesis there and then a parenthesis there in order to square it at the end. So make sure you're doing the square for the sine, not just the 3x. All right, number 2. Number 2 says, a portion of the function g of x is given above. So this is our graph right here. The arc length of the function gx over the interval from 0 to 3 is given by this equation. Find g prime of x. All right, now think about your equation. Your equation is from 0 to 3 of 1 plus the derivative squared. So that means that g prime of x quantity squared is the 4/9 x squared. So our g prime of x is going to be 2/3 x. Now the deal is, when you do the square root of this, and the square root of this, keep in mind you've got plus or minus. So what we need to determine, is this going to be positive or is this going to be negative? Because we would have squared it. And like, look at number 1. Number 1 was negative. You wouldn't have known that. And that's why they gave you the graph. Look at your tangent lines. You're talking about derivative. From 0 to 3, your tangent lines are all positive. Since you have positive tangent lines, that means your derivative should be positive. Now, if this were going the other way and your tangent lines were negative, then you would use the negative answer. Okay? All right, number 3. Number 3, very similar, just going to go a little bit further. So, portion of h is given. Here's our h. Arc length is given by this equation from 0 to 2 of this squared. Find the equation of the tangent line to h of x at x equals 0. All right, now, to find the equation of a tangent line, remember you need a point and you need a slope. Our point, we're finding x at 0. And so we look at our equation. This is just our function h. So at 0, it's going to be equal to 2. So our point is 0, 2. Now our slope. We need to find our slope. Well, h prime of x squared is right here. So it's going to be 2/3 e to the x over 3. So h prime of x is equal to 2/3 e to the x over 3. Now again, you know it's the positive version because look at our graph. Oops, up here. Look at our graph. All your slopes are positive. So you know it's the positive version, not the negative. Not to mention, they put it in parentheses for you. They didn't actually square it. So that makes life a little bit easier. All right, so we want to do h prime of 0. Well, that's 2/3 e to the 0, which is just 2/3. So your slope is 2/3. So you're going to get y minus 2 equals 2/3 times x minus 0. And you can just be done. All right, let's look at number 4. Quick check number 4. All right, consider the function f of x is equal to blah. The length of the curve of f of x from 0 to 4 is given by this. Find the value of a. All right, well, this is f prime of x squared. So the first thing I need to do is find f prime of x. Well, if f of x is equal to ln of 3x squared plus 2, then f prime of x is 1 over 3x squared plus 2 times 6x. Don't forget your chain rule. Okay? Now, this is equal to the square root of this. Well, now think about it. If you do the square root of the top, that's going to be the square root of ax. If you do the square root of the bottom, okay, that's easy. That's just going to be 3x squared plus 2. All right, well, now look at these. 6x square root of ax. 6 should equal the square root of a. Square both sides, and 36 should equal a. Okay? That's the end of that one. So again, remember, this formula had f prime of x squared. So we just found the derivative. We took the square root of this, set them equal to each other. We're able to find it. All right, our last quick check, number 5. All right, our last quick check of number 5. It says, let y is equal to f of g of 2 of x. Write the integral expression that represents the arc length of y from 0 to 5. All right, so L is going to equal from 0 to 5 the square root of 1 plus. Now, you got to do the derivative of this, which is 3 chains. So you're going to have, let me see if I can't get it up here, you're going to have f prime of g of 2 of x times g prime of 2 of x times 2 quantity squared. Now again, remember, the whole thing is being squared. This is your derivative. This is the derivative of y. F prime of g of 2 of x times g prime of 2 of x times the derivative of 2 of x, which is 2. So you just did a couple chains. And you're done. I didn't want you to go any further. And I just wanted you to write the integral. Okay, so that's kind of like our review of arc length. So let's go ahead and look at 2 examples where we're actually using the arc length. And the first one's a little bit easier, and like I said, the last one, good times. Let's take a look at it. All right, so we've got path 1 and path 2. Okay, path 1 and path 2. Tony and Brian, which are the name of the guys that are doing those videos, are starting at the origin and walk a closed path that's shown above to end back at the origin. So he's going all the way around this to get back to the start. Same here, he's going up, curving, here, back to the start. Tony follows path 1, Brian follows path 2. Path 1 consists of 4 segments and a semicircle. Path 2, 4 line segments, and the function of e to the x over 2. So this one's going to be where we're going to be doing the arc length. Okay? So you've got a little bit of regular and then a little bit of formula. So kind of nice. All right, who took the longer path? So what we need to do is we need to find the perimeter. So we need to find the distance all the way through. So now, because I don't want to write on my sheet over there, I'm going to go ahead and do path number 1. And I'm going to kind of sketch it out here. I'll use the numbers from my graph so you can follow along with the actual graph. I am just going to have this here. Number 2, it goes a little bit higher. It goes like this. There we go. All right, so in path number 1, the distance right here was just 2. Okay, we went straight up and down 2. The distance down here was just 5. It went all the way across from 0 to 5. Up here, this was from 0 to 2, so it's 2. Now we got to do a little figuring out right here. To find the distance of this, you don't have a formula, so you're not using arc length because you don't have an f of x to take a derivative of. But you know that it's a semicircle. Well, the distance around a semicircle is circumference, 2 pi r. Now, we only have half of a circle, so we're going to divide that by 2, so we're just doing pi r. Well, looking at your graph, okay, your radius here is just 1. Okay, so it's going to be 1 pi. Now, this right here, we're going to go ahead, and you could do the distance formula, or you could do Pythagorean theorem. So r squared is equal to 1 squared plus 2 squared, or r is equal to the square root of 5. Okay, so for path 1, you have let's get rid of these because those aren't part of our path. We're going to go 5 plus 2 plus 2 plus pi plus the square root of 5. Now, I'm just going to put that in my calculator as I see it, and I get 14.378. Okay? So that is the perimeter of path number 1. All right, let's look at path number 2. Path number 2 is going to have a little more work. So this distance right here is 1, not a big deal. This distance right here is 5, not a big deal. Ooh, we don't really know this one. I mean, at first glance you're thinking it's 3, but it doesn't go all the way up to 3. So we don't know how big that is yet. Let's deal with that for a minute in a second. Let's look at this one. This is the equation e to the x over 2. So we're going to use the arc length formula here. Okay? E to the x over 2. So the arc length formula, well, that's going to be from 0 to 2. Why 0 to 2? Because we're going from x equals 0 to x equals 2. Okay? That's what we want to find. The square root of 1 plus the derivative of this. Okay, well, if f of x is equal to e to the x over 2, f prime of x is equal to e to the u times the derivative of that u. So it's 1/2 e to the x over 2 quantity squared. Now, there's actually a little calculator picture right here, which tells you do want to use your calculator. I don't think they'll probably put that on the AP exam, but you're going to want to go ahead and put that in the calculator. So you got math 9. We're going from 0 to 2. The square root of 1 plus the quantity of 1/2. You can do 1/2 or you can do 0.5. E to the x over 2 quantity squared dx. Alright, we get 2.663. Alright, the distance up here is going from 2 to 5, so that's going to be 3. Now the distance right here, okay, we don't know how high that is, but could we find this point right here? If we could find the y value right here, then we would know the height of this thing. So the y value right here, well, it is the function f of x at x equals 2. So it's e to the x over 2, this one, this function right here, evaluated when x is equal to 2. Well, that's e to the 2 over 2, which is just e to the 1. So it's going to be e tall. So we have 5. plus 1 plus the 2.663, which, you know, some people would say don't round this until you get your final answer. And that's fine. I mean, you're just not going to be off by that much. And as long as you're doing 3 decimals and you're showing the work to get there, AP is going to be just fine. Plus 3 plus E. Now, E is 2.7, but again, we like 3 decimals, so I'm just going to leave it E when I put it in my calculator. So I'm doing 1 plus 5 plus 2.663, whoops, plus 3 plus E to the 1, and I get 14.381. So look at path number 1 and look at path number 2. They're super duper close, but path number 2 is faster, or longer. So I guess it's not faster, although pretty darn close. So they ended up going really close to the same, but path 2 is a little bit faster. All right, part B. Part B says, whose path created the region with the largest area? All right, so now we're going to find the area of both of these things. So how did I do that? Well, all right, let's go with number 1. For number 1, I broke this up into 3 different portions, okay? So this right here is just a square. 2 times 2 is equal to 4. Perfect. Now, this section right here. Now, I want to find the square minus the half circle, okay? Because I want to find the area right here. So I've got the square minus the half circle, okay? Here, hold on, I'm trying to figure out how I hold it. There we go. So the square is 4 minus the area of the half circle. Let's see the square. 2 is 4. The area of the half circle is pi r squared divided by 2. So r, we said, was 1. So pi, let me write up here, pi r squared divided by 2. So you're going to end up with pi over 2. Okay? Then I want to add the triangle. Well, that's going to be 1/2, and this is a 1, and this is a 2. So that's just going to be a 1 as well. So, in my calculator, I have 4 plus 4 minus pi over 2 plus 1, and I get 7.429. Okay, so that's the area of number 1. All right, so let's look at the area of number 2. Right here. Let's get the area of that section right there. How do we find the area of that section? I don't know what picture this is. Now, could you break that up into a square down here? I suppose, you know, that's 1, and then you got to find this. You're still going to have to do the integration. So might as well just do the integration of the whole thing. So let's take a look. And we're going to find this area right here. Well, remember, the area under the curve is the integration from 0 to whatever the x is. In this case, it'll be 2. Because again, look at your graph. Don't be confused by that 5. We're finding this area right here. So it's from 0 to 2 of the top minus the bottom. All right. So we're going to integrate from 0 to 2 of the top equation minus the bottom equation dx. Okay, so we're getting the area from 0 to 2, the top equation, which was e to the x over 2, minus the bottom equation, which was dx. All right, plus we want to add, let me come back up here, this is a rectangle. This rectangle is a 3 by, it's 3 by e. So 3 times e, that's our rectangle. That's your length, that's your width, or something like that. Or your width and your length, doesn't matter which one's which, it's just 3 times e. Because remember, the height of this is e. Now, remember, this is a 5, but this was 2 and this was 3, so it's 3 by e. All right, so we put that in our calculator. We have math 9 from 0 to 2 of e to the x over 2 dx, and we get that. And I'm going to add that to 3e, and I end up with 11.591. So, path 2 gives you the largest area. Okay? So, you get to see that, like, this first one, we're just finding the area of a regular. That's like AB stuff, right? And then we do area of the second one. Well, that's going to add what would be normally AB material, but because they're taking out area and volume, this is just BC for today, or for this year. So this would make this a BC question, essentially. All right, let's look at part C, which for sure is a BC question. It says, find the second degree Maclaurin polynomial for f of x. All right, so Maclaurin. Maclaurin is when a is equal to 0, and we have our function. Okay, of f of x. Well, f of x was equal to e to the x over 2. So the first one is e to the x over 2. All right, well, e to the 0 is just 1. Okay, now we got to do our first derivative and our second derivative. So our first derivative is e to the x over 2 times 1/2. So 1/2 e to the x over 2. If you plug in a 0, that's just going to be 1/2. Second derivative, 1/2 e to the x over 2 times another 1/2. That gives you 1/4 e to the x over 2. You plug in a 0 and you end up with just 1/4. Okay? The first one is 1, the second one is x, the third one is x squared over 2 factorial. And remember, it'd be x minus a, but a is just 0. So we end up with p, or f of x, is approximately 1 plus 1/2 x, and this is 4 times 2 times 1, so plus 1/8 x squared. They wanted us to evaluate that at 2. And we get approximately 2.5 or 5 over 2. They don't really care how you answer it, decimal or fraction. You can plug that into your calculator, you can do the math, or you know what, you can even stop, remember? You know, plug it in and be done. You don't have to go back through and type that in, especially if you're having some time issues. If you're having some time issues, then just stop and just leave it. This is perfectly fine. All right, let's look at number 5. Number 5, our exciting number 5. BC5. All right, so BC5 looks like it's just going to be a normal Riemann sum, but it has a little twist to it. It's kind of exciting. Let me get my other little sheet paper up so I can follow along what I did. So the function f is twice differentiable for all real values with f double prime of 0 equals this gross thing, which we're actually not going to use till the end. Select values of f prime, selected, of f prime of the derivative f are given in the table above. The arc length of the function f of x from 0 to x can be represented by the function s. S of x is the integration from 0 to x of, so it's like an arc length formula right here. All right, it says using the left Riemann sum with 4 subintervals indicated in the table, approximate the arc length of the function f of x from x equals 0 to 8. All right. So the arc length of the function f of x can be defined by this function s right here. So we've got to incorporate this in with the Riemann sum, left Riemann sum. All right, so let's just get started a little bit here. Yeah, let me get these out of the way. So we know that we're going from 0 to 1, from 1 to 4, from 4 to 6, and from 6 to 8. Okay? So distance here is times 1, distance here is times 3, times 2, times 2. And we're going to be using these left values right here. Okay? We also know that s of x is equal to the integration from 0 to x, and for this one we want to find from 0 to 8, of the square root of 1 plus f prime of x squared. Okay? Now, our table gives us f prime of x. We're going to have to incorporate using the left Riemann sum in order to solve this thing. Okay, because you don't know the functions. You can't find the derivative, and you can't just plug in the derivative. You can't just plug in one point. You've got to plug in the points as you go, and they want you to use the left Riemann sum to do so. So it's kind of like we're going to combine these numbers down here and this formula at the same time. Okay, now remember, this right here just means sum. And that is when you're using the Riemann sum. All right, so you're using Riemann sum, which is going to take care of this right here. So you just really need this portion right here in order to find the value. All right, so let's look at what we did for part A. All right, the distance of the rectangle is 1 times the square root of 1 plus f prime of 0 squared. Why 0? Because it's on the left. Okay? Plus 3 times the derivative of 1 plus f prime of 1 squared, because it's on the left. Plus 2 times the square root of 1 plus f prime of 4 squared, plus 2 times the square root of 1 plus f prime of 6 squared. Okay? So, the 0, the 1, the 4, and the 6. We're using those because those are our left values. Okay, if they had asked for right, we would have used the 1, the 4, the 6, and the 8. But they wanted us to find the left Riemann sum. So, let's go ahead. F prime of 0 was, F prime of 0 is the square root of 8. Square root of 8 squared is just 8. Plus 3 times 1. Plus the f prime of 1 was the square root of 3. Squared would just be 3. Plus 2 times. F prime of 4 was 0, so that's just going to be 1. Plus 2 times f prime of 6 was the square root of 3 squared, so that is 3. Okay? And we could put a plus 0 right there if we want to. Now, time constraints. If you're on a time constraint right now, boom, be done. Be done. Now, if you'd like to get a final answer because you like the way these things look, well, this is easy. This is the square root of 9, so that's 1 times 3. This is the square root of 4, so that's 3 times 2. This is the square root of 1, so that's 2 times 1. And this is the square root of 4, so that's 2 times 2. Your answer should be 15. Okay? All right, let's look at B. B says, using Euler's method starting at x equals 0, with 2 steps of equal size to approximate s of h, show the work that leads to your answer. Whew. It looks like you start off just fine, and then it's going to get it to be a doozy. It's an interesting one. So Euler's method, we know we got to make our table. X, y, change of x, dy, dx, and then change of y. We know that our first thing is 0. We don't know our first y value. You look all around and they don't tell you the first y value. So we're going to have to find that. Now, you're going to 2 steps to get to 8. Well, halfway between 0 and 8 is 4. So that means your change of x is going to be 4. Okay? Now, so far that's all you know. So now we got to start thinking a little bit. Now, we want to estimate s of 8. Okay? Now, s of x is equal to the integration from 0 to x of our square rooty thing. So the very first thing we need to know is, what is s at 0? That's going to be the integration from 0 to 0 of the square root. Okay, well that's just 0. because the area from 0 to 0 is nothing. So that's super helpful. Now, S prime of x. Now think about this. Okay? If you want this being S, and you want S prime of x, if this is S of x, isn't this the derivative, right? Because if you integrate the derivative, you're back to the function. So this right here is the derivative. Remember, we did that in class a little bit before we left as well. So our derivative is the square root of 1 plus f prime of x quantity squared. All right, so if I want to find the derivative at 0, s prime of 0 is equal to 1 plus f prime of 0 quantity squared. Now we already did that one. We did that one right here. And it was just 3. So we get a 3 right here. Okay. 4 times 3 is 12. Change of y plus 0 is 12. So yay, we got our second point. Now we need to find the derivative at 4. Okay. S prime of 4 is equal to the square root of 1 plus f prime of 4 quantity squared. All right, well, we did that one too. It's right here. That was 1 plus 3, which was the square root of 4, so that's equal to 2. That means this is equal to 2. 4 times 2 is 8. 12. Just kidding. We had a problem. Hold on. Oh, that should have been 1. There we go. Because, sorry, I was looking at the wrong one. It was over here. So, f prime of 4 was 0. 0 squared. Okay. So this is just a 1. 4 times 1 is 4. When you add 4, you end up with 16. So S of 8 is approximately 16. Sorry for the confusion right there. Okay. Any questions? Well, you can certainly send me an email. You can send me an email. I'll get right back to you. Every time, got to ask if there are any questions. I know that this was a toughie, and it's hard to know that you've got to use that S equation. But the way around it is knowing it says S of 8. And you've got to use that S equation when you're finding this 0. So just, look at how I started. S of x equals. And I said, okay, well, I want to find S of 0 first. So I plugged in my 0, found out that it's 0. I knew my change of x, so what's my derivative? Well, what's the derivative of S? Well, okay, I can go ahead and I can put it in. I know that my derivative is going to be this part of the function, which is how I got that right there. All right, last part. C. Let p sub 2 of x be the second degree Maclaurin polynomial for s of x. It's hard to say. Find p sub 2 of x and use it to approximate s of 8. All right, so this one starts off okay. It gets a little interesting. Not hard, it's just interesting. All right, so your function, you need to think of it as s, not of f, because you're trying to find the polynomial of s of x, not of f. So you first want to find s of 0. Well, we already found s of 0. Here's our s equation right here. S of 0 is going to equal 0. The next thing we want to find is s prime of 0. Well, we found s prime of 0 as well. S prime of 0 is equal to 3. Now comes for the exciting part. S double prime of 0. Now, let's say you get completely stuck and you're like, oh my gosh, I have no idea how to find S double prime of 0. Well, don't stop right here. You know that this is a 1, you know that this is an x, and you know this is an x squared over 2 factorial. So go ahead and write that part out. You're going to write P2 of x or s of x is approximately 0 times 1, which is 0, 3x plus something x squared over 2 factorial. At least show them that you know the process and you know how to make this table into some sort of an equation, okay? So make sure that you do as much as you can. Now, we are going to find s double prime, and we're going to find it at s double prime of 0, so don't you worry. But I'm just saying, get as many points as you can, show them what it is you can do. All right, so how do we find the derivative, the second derivative? Well, look, there's your first derivative. You already found the first derivative when you were doing Euler's method. So now we're going to find the second derivative. All right, well, what's the derivative of the square root? 1 over 2, the square root, times the derivative of the square root. Well, the derivative of of 1 is 0. The derivative of this is the chain rule. 2 times f prime of x times f double prime of x. Okay? Because you've got this sort of like the chain rule of f prime of x quantity squared, so that's your u. The derivative of u squared is 2u, so there's your 2u times the derivative of u, well, that's the second derivative. Now, we want to find s double prime of 0. So we have 1 over 2 times the square root of 1 plus f prime of 0 quantity squared times 2 times f prime of 0 times f double prime of 0. All right, so let's simplify this thing. What is f prime of 0? All right, look at the very top of your table. F prime of 0 was the square root of 8. So we have 2 times the square root of 8 times f double prime of 0. Ooh, look at the very beginning. Didn't they give that to you? That was negative 3 over the square, or 8, the square root of 2. All over 2 times the square root of 1 plus, that was f prime of 0. What was f prime of 0? 8, and then it was squared, so, or square root of 8, and so that's 8. All right, I'm going to get rid of those 2's. Let's simplify this. This can become a 4. Square root of 4 is 2. 2 times 3 is a negative 6 over 8. And then this is the square root of 9, so that's going to be a 3. Keep change, flip. I'm coming back up here. Negative 6 over 8 times a 1/3. That gives you a negative 2 over 8, or a negative 1/4. Aha! So this is a negative 1/4. So this would be a minus 1 over 4 times 2 times 1, which is 8, x squared. Oh, sorry, kind of fallen off the page there for you. Now, you needed that 1/4, but keep in mind, all of this stuff, I probably could have just put that in my calculator. Let's use my alpha y equals, and I've got 2 times the square root of 8 times another alpha y equals, let's do another fraction up there, a negative 3 over 8, the square root of 2. And then on the bottom, I've got a 2 times the square root of 1 plus 8. Let's see. Look. So you don't have to do all of this math. Okay? You just put it in your calculator as you see it, and it will do all of that ugly math for you, and you get negative 1/4. Now here's the deal. If you do all of this work is worth some credit anyway. So if you get this equation, but then you get the negative 1/4 wrong, you're getting points for knowing that you had to take the second derivative of that s prime thing. Now to finish this off, last section, s of 8. Then you've got approximately 3 times 8 minus 1/8, 8 squared. That's going to equal 16. Again, you can stop right here, or you can type it in your calculator to get the 16, but the 16 is that final answer. So that's kind of a mess, but that's our final answer for that. Okay, so that shows you how it can take Euler and Maclaurin and just like blow it up. But of course, remember, you can have all of this stuff with you. So maybe you make a little notebook with all of these little videos organized. And so if you're like, oh gosh, I remember seeing that, how did I do that again? You're not going to want to search forever. You're going to want to do more writing than looking. So you're just going to want to get started and then just fly through the problem. Think about if you were taking the AP test in the beginning. I mean, like if it weren't COVID and you were at school, you wouldn't have had anything. You would have just, used your brain and would have gone and taken it. And I kind of feel like that's what you should do now too. And I was talking to Elizabeth, who took the AP test last year, and she was like, "What? They have 2 questions and they get to use all their notes?" And I said, "Would your notes have really helped you?" And she thought about it, and she said, maybe not so much. Now, formulas and remind you how to do Euler, remind you how to do Maclaurin, sure. Your notes can help you do that, but they're not going to be able to do problem by problem. You're just, mostly you're going to have to get started, try something, and then go with it. So, all right. I hope this helps. Bye.